Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video, let us try to understand the concept of dead letter queue in Apache Kafka. Okay. So already in our previous video, we discussed dead letter queue or DLQ in the context of SQS in AWS, right? That is, whenever some event our system or pipeline is not able to process from SQS, then after certain retry also, if it is not resolving the issue, then the messages or the events are moved to DLQ or dead letter queue, right? If you want to know the detailed explanations, you can go through the link given in the description box. Now the same concept is applicable in Kafka also. How we can add this particular feature in our big data real-time pipeline to make our whole system more reliable and fail-safe, that we are going to cover today in this particular video. Okay, right? So let's first observe one simple architecture. Suppose here we are having our Kafka producer, okay, which is getting the messages in real time from different source systems, maybe IoT system or some other sensor data, and then it is publishing those messages, events or real-time data to a particular Kafka topic. Okay. From this topic, what is happening in the consumer side, here we are having a connector running. And because the connector is in consumer side, so obviously it will be termed as sync connector, right? Already we discussed. So here our sync connector is consuming the messages from the topic and then writing in an external system. Okay. Maybe that is some cloud data warehouse like Snowflake or S3, etc., etc. Now think like this way. Suppose the producer is producing some bad data or corrupted messages. Then what will happen? Suppose the sync connector is consuming the message, and while consuming that bad data, this sync connector is failing. Okay. How to handle that failure scenario? That let us try to understand. Okay. There are different ways you can handle a failure scenario in this case. What are those? Let us try to understand with a tree diagram. So as soon as the sync connector will face the error in reading the message from a particular topic or while writing in that external system, what you can do simply, you can fail the sync connector, so that using some alert functionality, the alert will be going to the data engineers or admin team or production support team, and they will come and check what exactly happened, right? So here we will build the tree based on error tolerance. That is how much error our sync connector can tolerate, right? So here parent level I can write as error tolerance. Okay. I can make a box here. So based on error tolerance, first approach what we can do, that as soon as error occurred, fail the connector. So that approach is called as fail first. Okay. What other option is there? Other approach is, if you don't want to fail it, handle it. Okay. So in the next child, we can handle the messages in two ways. Okay. One approach is, let error occur, we will silently ignore them. Okay. So the approach is called as silently ignore bad messages. Okay. And what is the another approach? The another approach is, write those bad entities in a separate place so that in future further investigation can be done on that data. And there comes our DLQ. Actually the DLQ or dead letter queue word goes better way with SQS. We can call this as DLT also. That is, sync connector will try to read the data from the topic. If it is not able to read that, what it will do? It will write in a separate topic. From that topic, you can send some alert to the developer team or admin team, etc. This particular topic is termed as dead letter queue or dead letter topic. Okay, clear? I hope you got it. Now, how we can configure this kind of different error tolerance in our connector? So there is a parameter, and that parameter is error dot tolerance. Okay. So if error tolerance you are making as none, that means it will have no error tolerance property. That is, as soon as some corrupted message it will try to process, and if it fails, then and there our sync connector will go down. Okay, right? So this particular property, I hope you can easily get it from the name itself. What it is doing, it is basically fail fast approach. That is, as soon as we are getting error, we will fail that. Okay. The next tree is silently ignore bad messages. So here same property, error dot tolerance, you can make as all. Okay. That is, whatever number of bad messages are coming, let it come, no problem. Our connector will not fail. Our connector will only take the good messages or correct data and write in the external system. Okay. It will simply ignore the corrupted or bad messages. So in case of silently ignore bad messages, you can just configure error.tolerance equal to none. That's all. Okay, because we are not at all bothered about the bad data or bad messages. But in case of DLQ, what should happen? Two things. One is our connector should not fail for whatever number of bad messages coming. So obviously we need to configure error.tolerance equal to all. That is, no limit for how much wrong data is coming, let it come. But along with that, we need to configure another property, that is, what is the topic name in which the bad data will be written. Because in this DLT or DLQ approach, we need to capture those data also, right? So in which Kafka topic it will be captured, that also we need to mention. So these are two very important points when you are configuring any connector which is having failure handling property. In that case, you need to configure these two also. When I will show you the lab section, it will be much more clear. So let's try to understand the same DLQ approach with a real-time experiment. Okay. So in our case, what we are going to do, we are going to use Snowflake sync connector, and we are going to publish some bad data from the topic, and we will see that our sync connector is failing. But we will configure the dead letter queue in that sync connector, and we will see whether that corrupted messages or bad messages what our Snowflake sync connector is not able to consume, whether they are going to the dead letter topic or not. Okay, right? So let's see what is the configuration we have to do. So here two configuration set I have written for our Snowflake sync connector. The left hand side is basically what we already discussed in our previous video, and the right hand side is basically with the DLQ functionality or dead letter topic functionality. Okay, so let's compare them quickly. So first key value pair what we configured in our Snowflake connector is connector.class, which is same for both cases, no change. Okay, then task max, anyway here we are doing just a POC, so you can give any value, but when you are moving to production you need to choose wisely, because depending on this speed will obviously differ. Then here topics, from what topic the Snowflake sync connector should read the data and write in Snowflake table. That topic name here we need to provide. Same thing here also coming. Okay, there is till now there is no difference. Then here this property, Snowflake topic to table mapping. That is, what topic data should be going to what Snowflake table. That mapping we are doing here. Same thing is done here also. Okay, sorry for this line. Now then here buffer count records, buffer flash time and buffer size bytes, depending on that flashing happens, right? Same thing is available here, no change. Okay. Then Snowflake URL name, Snowflake username, Snowflake private key, database name, schema name, all are required to help connector to understand where the data should be flashed and based on what authentication should happen. Same thing we are doing here, no change. URL name, username, private key, database name, schema name. Okay. Now here key converter, how the key should be treated and it should be serialized, etc. So because we are handling JSON data, so I used Snowflake JSON converter. In this particular configuration, I am using string converter, but that is actually not mattering much. You can use string converter for plain text data. You can use JSON converter for processing JSON data. For Avro, you can use Avro converter, etc., etc. You can check the documentation. Lot of other converter you will be getting. Okay. Because here we are not going to check the key part, so you can use anything. I have used here string converter because key anyway we are not passing, so plain text format is also fine. Now here key converter schema enable equal to false. Okay, so key we are treating as plain text, so obviously schema not even required, so I am keeping false only. Then here this is very important. Here changes start. Okay, In our earlier case, where we were not having the DLQ functionality, there in value converter, we were using this value, com.snowflake.kafka.connector.records.snowflake JSON converter. Snowflake JSON converter we can understand because this is basically used to handle JSON data. In this case also, if you see, JSON converter is there, but it is not Snowflake JSON converter. Okay, why? Because as per documentation, if you want to implement DLQ functionality in Snowflake Sync Connector, in the value converter for JSON converter, you have to use this one instead of Snowflake JSON converter. Okay, so earlier we were using com.snowflake.kafka.connector. Now we are using org.apache.kafka.connect.json. That's one. Okay. Now here, because we are working with JSON data, you might be trying to superimpose or validate this schema. So for that, you can define the JSON schema in schema registry, or in the payload only you can put. So if you want to do those kind of schema validation, you can obviously make schema enable true. But because we are doing a POC, we are not bothering about that part in the schema validation. So we are keeping this false. Okay. The name property was there earlier also. The name is basically indicating what is the name for this our connector. These three properties are specific to our DLQ feature. Error tolerance equal to all. Just now what we discussed in the theory part, right? That is here we discussed now that error tolerance should be kept as all in both cases. That is whether you want to silently ignore or you want the DLQ functionality. That is whatever error messages coming, let it come. Snowflake Sync Connector will not fail for that. So for that we need to configure this property. That is error.tolerance equal to all. Then in which topic our corrupted messages should be written, that we are configuring here. Error.deadletterqueue.topic.name equal to this. This is the topic name, you can give anything. Okay. And then as you know that in messages we are mostly having key, value, timestamp, etc. Along with that, nowadays header is also added. So if you want to pass some more information via header, so you can keep this header.enable also too. But that is actually not mattering much. As part of DLQ implementation, this property plays a very vital role, JSON converter. Then here this error tolerance all and the topic name. These are very vital. Okay. I hope you got it. You got some idea. For more detailed explanation, you can check the documentation link, which I'll be providing in the description box. Now let's implement the same and let's see the corrupted messages are going to DLQ or not. Okay. So here what I will do, I will open my notepad file and here I need to follow some steps. As a first step, I need to create the public key and private key for authentication, which we did in our previous video also. So to store the public key and private key, here I created a folder in my Kafka location. Snowflake key is the folder name. Let me open command prompt here. And then here let me go to Windows subsystem for Linux because we want to use the openssl code. Here I will generate the key. That is done. Now I will generate the public key for that. That is also done. If I go to this directory, here see public and private key got generated. Let me configure the public key quickly in Snowflake. So here I will edit with Notepad++. This is our public key. I will copy that. I will go to Snowflake. In Snowflake here, if you recall our previous video, we already did this. We are dropping a database, creating a database, and that user, what our Kafka will be using for publishing the data. For that, we are configuring the public key because based on public key, private key, the authentication will happen. This is done. You can execute describe user command to check whether the RSA public key properly configured or not. Let me do that. So here if I scroll little below, here you will see in the public key component, the value part, it is configured. Okay. Now here if I do show tables, here as of now, because just now we created the fresh database, no tables are there. Okay, cool. Now here let's start our Kafka framework. So now what we will do, we will start our zookeeper. I'll go to terminal, I'll paste this and start our zookeeper. Then here I will start the broker in a new window. And I will create a Kafka topic. So here if you see the topic name where actually the messages should be published is demo testing 3. From here our Snowflake Sync Connector will consume the data. Okay. So that one I will create. And another topic is required where the bad messages will be flashed. Right. So that topic name I am providing this way. DLQ sync 1234. Okay. So here I will paste that and see here that also got created. Right. Now here what we'll do, we'll start our producer, but before that I will start the Snowflake sync connector. So here if you see, we are passing the sfconnect.properties file. So let me show you that properties file once. Here if you see that connector class task max topic name, that is from this topic our Snowflake sync connector should consume the data and then write in this particular table. As of now we have seen that no table is existing in Ramu database because we created that database freshly, right? So nothing is there. Now what we'll do, based on these conditions the data should be flushed. Here I have given the URL name for my Snowflake account, the username, the private key we need to provide. So private key is basically we created just now, right? So that private key I will configure. This is the one. I will copy that and paste here. Okay. To make a single line, I will make sure these things are there. Okay, cool. Then here database name. In Ramu database just now what we created there, it should be flushing the data. Within that public schema the table should be available. Key converter, value converter already we discussed. The name of this should be demo123 and error tolerance, and these three properties are specific to our date letter queue. Okay, so I will save this, and now what I will do, I will start our connector. Okay, let the connector start. And we'll start our producer for this particular topic in a new terminal. And then here we will start another console consumer pointing to this topic. So for this topic there will be two set of consumer. One is our Snowflake sync connector, one will be the console consumer. This we will start to see whether messages are coming properly or not. Okay, and another console consumer will start on top of our date letter topic. Okay, to see the corrupted messages are reaching to date letter topic or not. Okay, as simple as that. Cool. Now here if you see, here our Kafka connector is running, and in the producer part what we will do, we will start publishing some good messages first. So let's publish hello world. Okay, then next message I can pass hi there. The next message I can pass 1 2 3 4. So if you see, all these messages are following proper structured JSON format, and here in our value converter we are using JSON converter only, so it will not at all have any problem in flushing those messages to our Snowflake. So earlier we had no table. Let's see whether table got created or not. So see, just now table got created. If I just now do select star from this table, here as of now only one record came, and other two records what we published in this topic soon it should be coming. Okay, and if you see the normal console consumer, here all the messages came. Okay, and in the date letter topic no messages came because it is not having any issue with these messages. So let's see in our Snowflake whether it reached or not. So see, all messages reached, right? Now let's publish some bad messages. Okay, so here I am passing a string which is actually not following the JSON structure. So data, this way I am passing. Okay, then I am passing hello world. Okay, hi there, another bad data. Okay, then I am publishing some good data also, maybe 56. Okay, and then hi YouTube. Okay, right? So this is basically a good JSON data, but these are bad data, right? Our JSON serializer will not perfectly fit on this because this is just raw string we are passing. In the console consumer, if you see, all messages will be coming, which is obvious because this is just consuming the message irrespective of its structure. Here we are not mentioning any serialization technique. So by default, it is treating all as plain text and it is consuming. But ideally, what should happen in case of our Snowflake sync connector, it will consume only this message and write in Snowflake, but these three messages it will not able to consume. It should be sending to date letter topic. Let's see. So here I will query, select start from this table again. And if you see 1, 2, 3, 4, I think this is older messages only. So this is the new message what we published. This has not came yet. Let's see the logs for our this one, console consumer, and here this is running. Let's see our date letter topic. What is the situation? See, in date letter topic, data hello world hi, this is another bad data. These are coming. Because these are bad data, our Snowflake sync connector is bypassing those data in this DLQ. It is not failing. Okay, that's the funda, right? It is not silently ignoring bad messages. It is routing the bad messages to another topic. From there, another consumer can consume and make some alert to developer team, etc. Okay. Now there is one message what we published, which is 56 hi YouTube. That should be going to Snowflake. Let's see. Here if I run, here it has not reached yet. Oh, it has reached, sorry, 56 hi YouTube. Okay. So that message has reached, which is correct one, right? So if you see, there are total 4 correct messages. And here we published 4 correct message only, right? So they are coming. Only bad data are not going. So I hope you understood. This way this particular configuration is implementing date letter queue functionality in Snowflake sync connector. Now we should not be stopping here in the production level especially. This is a POC, I explained you, that is fine. But when you are moving to production level system, what architecture you should be following? That is, as soon as some messages are coming in our date letter topic or date letter queue, the alert should be going to the respective team. So let's see that architecture also. So here this architecture explains that pipeline. Okay, let's try to understand this. So here, suppose we are having user or maybe some entity which is generating real-time data. If you are considering user, then what user can do? User can enter in a public subnet EC2 using SSH, okay, to publish some data. Okay, and here our MSK cluster in AWS, maybe they are running with 2 brokers to make our whole system fault tolerant. One is running in public subnet A, AZ1, another one is running in AZ2. Okay, right? Let me give the name as AZ2. Right? Now what will happen that from this EC2, maybe the messages are getting published via this MSK broker to a particular topic. And from this topic, actually the destination is Snowflake Cloud Data Warehouse platform. So what you can do, you can configure a Snowflake sync connector which will read the data from that topic and then publish in Snowflake. From there, data engineers can do analysis on that real-time data. Okay. But what if some bad data or bad messages are coming? That time you can implement the DLQ functionality in this connector and you can mention in what topic the messages should be sent, that bad messages, right? So suppose the bad messages you are sending to another topic. Now up to this we have seen in our local system. Now what is the next step? The next step what you can do, in many companies this particular architecture is followed to make some alert notification. That is, from this topic you can create another connector which is S3 connector, and you have to configure the S3 connector such that it will consume all kind of data, not like JSON or Avro specifically. Any data it will treat as plain text and it will consume that, not at all a problem. That S3 connector will publish those bad entities in a S3 location. From S3 location, using event based notification, you can trigger a Lambda code. In that Lambda code, you can take help of SNS, or you can take help of simple email service, that is ACS, okay, to send email or any push notification or SMS message, whatever, to the developer team or production support team, okay, so that they can quickly come and check what are the reason for which the error occurred, or what are the bad entities which are creating issue in our pipeline, okay. And another good thing in this kind of architecture is the bad messages are also having a backup in our S3. Maybe what you can do, you can run a glue crawler on top of this data, and then you can update a Athena table. That Athena table, our production support team can query to understand easily what is the reason for the message failure. Okay, right? So this is how alert functionality along with DLQ is implemented in production system. I hope you understood this. This is all for this video. If you find this video helpful, then please like, share and comment, subscribe our channel if you are not subscribed till now. And don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.